All right, now on to chapter 11, problem 7. So chapter 11, problem 7, you have to have the figure 2 from that chapter, um, which is the force and the distance, the force applied over a distance. So a couple of things. This is basically this setup with the protein they have is basically analogous to a spring. So for a spring, your force equals the spring constant times the displacement distance, right? So force equals kx, and the work done, or this is also the energy stored in a spring, the work done on a spring to stretch it, the energy stored in it is 1/2 kx x squared, right? So the force on a spring is proportional to the distance of displacement. The work done on it is 1/2 kx squared. And what we have here is a question of how much work was done in going from 10 nanometers to 15 nanometers, right? Well, what is work? I know for the spring, work is 1/2 kx squared, but in general, work is force times distance, right? Force times distance. So, but we don't have a constant force. What we have is a changing force applied over a distance of 5 nanometers. So how do we calculate the actual work done? Well, we use a graphical method. And the graphical method basically says the work done is the area under the curve, right? The area under the curve. So what is the area under the curve? So the work is, the area is, we've got 100 piconewtons, right? 100 times 10, a piconewton is 10 to the minus 12 newtons minus 0 newtons is the amount of work. The distance is 15 nanometers, and nanometer is 10 to the minus 9th, right? 10 to the minus 9th meters minus 10 times 10 to the minus 9th meters. And because it is not a rectangle but is a triangle, right? Because it's a triangle, the overall factor out front is 1/2. So 1/2 the change in force times the change in displacement. Okay, so simplifying just a little bit, this is 1/2 of 100 times 10 to the minus 12, right, is 10 to the minus 10th. 10 to the minus 10th newtons times, and 15 minus 10 times 10, so that's 5 times 10 to the minus 9th meters. So this is 10 to the minus 19th, 2.5 times 10 to the minus 19th Newton meters. All right, 10.5 times 10 to the minus 19th Newton meters. So we get, in this case, and a joule work is 2.5 times 10 to the minus 19th Newton meters is 2.5 times 10 to the minus 19th joules. So what other things? So the answer is C. What other things did we encounter in this problem? Well, other things we encountered is that a piconewton is 10 to the minus 12 newtons. A nanometer is 10 to the minus 9th meters. work or energy is in Newton meters, which are equal to a joule, right? Work and energy are Newton meters, which is equal to a joule. And those are the other things we encountered in this problem. And that's it for problem 7.